This is section 1.3, an introduction to polynomial functions. We've been looking at, first of all, linear functions, and now we're going to start looking at functions that have higher powers of x. Because vocabulary is so important in order to understand math, this section is really just going to review the vocabulary associated with these polynomial functions. First of all, each term of a polynomial is the product of a real number and then a whole number power of x. The real number, the numerical multiplier, is called the coefficient of the term. And then the x to whatever power, the power of x itself, rather, is called the degree of the term. A polynomial function is the sum of as many of these kinds of terms as you like. Polynomials sometimes are given special names based on how many terms they have. So if a polynomial only has one term, we call it a monomial. With two terms, we call it a binomial. And with three terms, a trinomial. If we've got more than three, we usually just use the generic term polynomial rather than inventing any more language. So let's practice the vocabulary just a little bit on a specific polynomial. F of x is 5x cubed minus 8x. Because there are two terms, this could be called a binomial. And my first term is the 5x cubed. The coefficient, the numerical multiplier, is the 5. And the degree, or power of x, would be 3. The second term is the negative 8x. And notice that the sign does come with it. So the coefficient, numerical multiplier of negative 8. And the degree here is actually 1. Usually, of course, we don't write the power 1, but it's there nonetheless. So the degree would be 1. All right, let's try this one more time. Our next polynomial function, x squared plus 4x minus 7, has got 1, 2, 3 terms. So we could call this a trinomial. Our first term is just the x squared. And very much like what we discussed with the power last time, this time it's the coefficient. It's really 1. We know 1 times anything is still itself, so I can think of that as having a multiplier or coefficient of 1. The degree would be the power, 2. Our next term is the 4x. Coefficient is 4. Degree is that power of 1 that's not written. And then our last term, the negative 7. The negative 7 is its own coefficient. And since there is no x, we say this has a degree of 0. Just a comment. X to the 0 power, if you remember, is actually 1. Anything, in fact, to the 0 power other than 0 itself is 1. So that's why that degree is 0. All right, in addition to defining the degree of each term, we can also define the degree of the entire polynomial, which is simply the highest power in the polynomial. The coefficient of whichever term has that highest power is called the leading coefficient. Polynomials can be named based on their degree as well as on the number of terms they have. And we've got a few examples of common polynomial types here. All of these examples, or little generic examples, I guess, are written in what we call descending order. Notice what that means is that we always start with the highest power first, and then the powers work their way down until we get to the constant term. That's what we mean by writing a polynomial in descending order. If there are no x terms, we just have a constant that would have degree 0, and the leading coefficient is the only coefficient, a. A linear function has only a first power in it, so the degree is 1, and my leading coefficient is still a. A quadratic function will have a second power in it, so the highest power is 2, degree 2, and because of the way this is written, my leading coefficient is still a. If the highest power is 3, degree 3, we have a cubic function. Once again, a has been written as our leading coefficient. And with the highest power 4, we sometimes call that a quartic function, degree 4, and again a leading coefficient of a. Beyond that, we rarely discuss a special name, and we just simply refer to the polynomial as 5th degree or 6th degree, or whatever the case might be. So here's a sample polynomial for us to work with. First of all, I'm going to take my polynomial g of x and write it in descending order, meaning I'd like to start with the highest power of x, which would be the opposite of x cubed, and then work my way down. Plus 4x squared would come next. There are no x to the first terms, so finally I just put the plus 9 last. Highest power is 3, so the degree is 3. And the leading coefficient would actually be the coefficient of this x cubed term. With the minus sign there, that's actually a negative 1. Two possible names I could give this. Based on the degree 3, I could call it a cubic polynomial. But also from the previous page, because it has 1, 2, 3 terms, I could also call it a trinomial. So depending on whether I want to name by degree or by number of terms, both of those would be appropriate. Let's try this one more time. My next polynomial function, again starting with writing it in descending order, looks like the highest power here is the 2x to the 4th. And then I would have a plus x cubed, a negative 5x squared, and a plus 6x. There doesn't happen to be a constant term this time. Degree would be the 4, highest power, and that means the leading coefficient is the 2. We could refer to this as a quartic polynomial because of the degree 4. But with 4 terms, we don't really have a special name based on the number of terms. We would just refer to it as the generic name polynomial. All right, just a real quick sort of preview of coming attractions. As we study polynomials throughout Unit 1, we've already taken a look at the linear ones back in the preview chapter, and we'll spend about the first half of this unit covering the quadratic ones. Usually you've seen those in beginning algebra, so we'll treat most of those topics more or less as review. And then the second half of the unit, we'll be talking about higher order polynomials, degree 3 and higher. And we definitely treat this as a new topic. And again, that will come near the end of this section.